Now, let's talk about domain and talk about some actual Lewis structures. In front of you, you can see methane, CH4, ammonia, NH3, and carbon dioxide here being CO2. The Lewis structures are below. Again, when you're looking at the domain, look at your center, and your center is always the very first element in your formula. And you count how many attachments are to the center. I see 1, 2, 3, and 4. This domain is 4. I see 1, 2, 3. Oh, I see an electron pair. This counts as an attachment. There's an electron pair. So this is actually the 4th. This domain is also 4. And with carbon, there's 1 oxygen here, and the second one is here for a domain of 2. Again, as a refresher, bonds don't count for domains. You're just seeing how many attachments there are. There's 1 here and 1 here. Okay, they're connected twice. It's still a connection. So don't count the number of bonds. Maybe it's easier to count the elements and the electron pairs. So here you can see the domain is 4 for both of these, but these two act very differently. And that's the power of the electron pair. Now, in the last video I mentioned that domains were really, really powerful. I made another little flowchart. Here's a list of all the domains that an element can have. If you have a domain of 1, you're going to be linear. And maybe look like this. Again, here, there's really no center, so pick one. This is connected to that, and that's it. That's a domain 1. That's 180 degrees apart. A domain of 2, for example, the carbon dioxide that we just showed, looks like this. That's also 180 degrees away from each other. Again, electrons hate each other. They want to get away. So the best way to do that here is 180 degrees. When your domain goes to 3, however, you create the trigonal planar shape we've talked about. I apologize, it just, this one's magnet, so it just stuck to something. Here, 3 things need to separate. 1, 2, and 3. And maybe one of these is an electron pair. But because there are 3 things now, you can't do 180. If you did 180, I'm going to move this just a little bit more for everybody. Do you see how these are pretty small now? This is like 90. Let's try to get this a little bit better for everybody. I apologize, the magnets are fighting with me as I do this one-handed. But essentially, 90, 90, 180, it hates the 90s. So it would rather spread out and have everything be the 120, domain 3. Domain 4 is where things get interesting. And again, for these, you can have tetrahedral, trigonal, pyramidal, and bent. This is a tetrahedral. Every single one of these bond angles is slightly over 90 degrees and is 109.5 roughly degrees. Kind of looks like the Eiffel Tower a little bit, maybe if I position it like that. A lot of people think that this would look like, you know, a plus sign. Have it be 90, 90, 90, 90 all around. The problem is atoms are 3-dimensional. So here, we're allowed to play with the 3rd dimension. So, the z-axis. We can go up and down, left and right, and towards you and away from you. This allows us to do that, as you see this atom, say, is in the back. And Domain 5 and 6 are a little bit more complicated. Domain 5 is trigonal bipyramidal. I do apologize. I'm trying to make it one-handed, so that's a little challenging. I do apologize. And my other hand has the camera. Kind of. So the magnets don't like each other either. So that's why it's kind of hard for me to make, because they're trying to repel each other. Here's a trigonal bipyramidal. Again, the top and bottom ones here, that's 180 from the one I'm holding to the bottom one. But there's a 90, there's a 90, there's a 90, 90, 90, 90, and there's some 120s. 120, 120, 120. And you can see all of them are represented right here. And domain 6 is octahedral. And octahedral ends up, and again, this one, again, the magnets don't like each other, so even the magnets are trying to separate. There's a bunch of 90s. Everything is 90 degrees on this. So, a little bit longer of video kind of introducing it. Throughout this lab, we're going to give you different Lewis structures to do and have you look at different domains, have you look at bond angles, and have you look at shapes. As a reminder, trigonal planar or a bent 120 can be a domain 3. And for domain 4, you could be a tetrahedral, trigonal pyramidal, or bent, depending on your number of bonds. 4 bonds, no electron pairs. 3 bonds, 1 electron pair. Let's keep going through the activity.